I'm going to show you a way to prepare slides that stay alive for days, weeks, maybe months. Here's what you need. Standard microscope slides. Slips. You can use the 22 by 22 millimeter slips, but I prefer the 20 by 20 millimeter size since it gives me more working room around the edges. A permanent marker Sharpie to write on the slide. An adjustable pipette. I recommend 100 or 200 microliter capacity. I'm seeing these sold for $20 to $30 new on Amazon. Pipette tips. Tweezers to get algae on the slide. Oil. I use baby oil, but I expect any light-grade transparent mineral oil would work. Distilled water. A small wax candle. A humidity chamber, that is just an airtight, watertight box with saturated paper towel and spacers to keep the slide above. A sample or culture of pond life that contains algae. A microscale with 1 milligram resolution. Mine cost about $25 and works great. You can do all this without the scale, but I find it helpful in keeping track of water loss through evaporation prior to sealing the slide and in predicting the thickness of the sample. Start by rubbing the edges of the slips with wax. This helps the oil to adhere and make a seal. Now weigh the slide with the slip. The first is 5.291 grams. We'll call that 29C and write the weight on the slide as well. The second is 4.900 grams, calling that 29D. Now I add sample, a bit of algae spread over the desired area. Then add the desired amount of water from the sample, 60 microliters in this case. Check the slides on the microscope now to see if they show what you're looking for. C shows rotifers, Paramecium bursaria. D shows those and also gastrotrich. Now weigh the slides again. C is 5.365 grams. D is 4.959 grams. Now seal the slip edges of slide C with oil. Note, I spazzed out with C. I didn't ruin it, but didn't get good video, so I'm showing oil application with a new slide. Then weigh it again. 5.383 grams. It should be stable at this weight over a long time at ambient conditions. For this demonstration, slide D is not sealed yet. Instead, I place it in the humidity chamber, which will prevent evaporation. Now we take D from the humidity chamber and view it for a while, seeing lots of interesting life. After about a half hour, we weigh it again, getting 4.942 grams, or a loss of 17 milligrams, to evaporation. We replace this with distilled water. Then place the slide back in the humidity chamber. This viewing and evaporation replacement can be repeated multiple times prior to sealing, and you can do other manipulations like feeding with your choice of nutrient. I sometimes add a trace of oatmeal slurry to the edge. For either of these long-term systems, it is important to have light exposure so the algae produces oxygen and keeps the microbes alive. I find the oil-sealed slides especially useful for time-lapse videos. I've been able to watch rotifer eggs develop, vorticella reproduce, algae grow, dead microbes get consumed by scavengers, some of these processes taking several days without moving the slide. In fact, that's why I had to get a second microscope, but that's another story.